Intro to Pipeline Automation 2. 3. Automated testing. In the old days, testing was quite a tedious and manual process. A tester would have to manually run and document every test case and hope that the coverage was sufficient to ensure that the application or service works and will remain stable. However, in modern pipelines, automated testing can do a significant portion of this. First one is unit testing. This will be the first type of testing that most developers and software engineers are familiar with. A unit test is a test case for a small part of the application or service. The idea is to test the application in smaller parts to ensure that all the functionality works as it should. In modern pipelines, unit testing can be used as quality gates. Test cases can be integrated into the continuous integration and continuous deployment part of the pipeline, where the build will be stopped from progressing if these test cases fail. However, unit testing is usually focused on functionality and not security. Second one is integration testing. Where unit tests focus on small parts of the application, integration testing focuses on how these small parts work together. Similar to unit tests, testing will be performed for each of the integrations and can also be integrated into the CI/CD part of the pipeline. A subset of integration testing is regression testing, which aims to ensure that new features do not adversely impact existing features and functionality. However, similar to unit testing, integration testing, including regression testing, is not usually performed for security purposes. 3. Security testing. See about SAST. SAST works by reviewing the source code of the application or service to identify sources of vulnerabilities. SAST tools can be used to scan the source code for vulnerabilities. This can be integrated into the development process to already highlight potential issues to developers as they are writing code. We can also integrate this into the CI/CD process. Not as quality gates, but as security gates, preventing the pipeline from continuing if the SAST tool still detects vulnerabilities that have not been flagged as false positives. Then DAST. DAST is similar to SAST but performs dynamic testing by executing the code. One method that DAST tools use to find additional vulnerabilities, such as cross-site scripting, XSS, is by creating sources and sinks. When a DAST tool provides input to a field in the application, it marks it as a source. When data is returned by the application, it looks for this specific parameter again and, if it finds it, will mark it as a sink. It can then send potentially malicious data to the source and, depending on what is displayed at the sink, determine if there is a vulnerability such as XSS. Similar to SAST, DAST tools can be integrated into the CI/CD pipeline as security gates. Penetration testing. Sadly, SAST and DAST tools cannot fully replace manual testing, such as penetration tests. There have been significant advancements in automated testing and even in some cases, these techniques were combined with more modern approaches to create new testing techniques such as IST and RASP. Do not perform well against contextual vulnerabilities. For example, a common vulnerability is when part of the process can be bypassed, for example, the credit card validation step. This is an easy test case to perform manually, but since it requires context, even DAST tooling will find it hard to discover the bypass. Similarly, business logic and access control flaws are hard to discover using automated tools, whereas manual testing can discover them fairly quickly. It is not that automated tooling will never be able to find these flaws, it is simply more cost-effective to use manual testing. Tools. There are several common tools that can be used for automated testing. Both GitHub and GitLab have built-in SAST tooling. Tools such as SNYK and SonarQube are also popular for SAST and DAST. SNYK, if your team prioritizes open source security and container protection, SNYK is an ideal choice. SonarQube, on the other hand, if you focus on comprehensive code analysis and overall code quality, SonarQube may be the preferred option. Case study, she can't take any more captain, she's gonna blow. A common issue with SAST and DAST tooling is that the tool is simply deployed into the pipeline, even simply for a proof of concept. However, you need to take several things into consideration. Performance cost. Integration points. Calibration of results. Quality and security gate implementation. When introducing new automated testing tooling, careful consideration should be given to how a POC should be performed to ensure that no disruptions are caused but also to ensure that the POC is representative of how the tooling will interact when it is finally integrated. A fine balance to try and achieve. 4. Continuous integration and delivery. In modern pipelines, software isn't manually moved between different environments. Instead, an automated process can be followed to compile, build, integrate, and deploy new software features. This process is called CI/CD. CI/CD. Since we are constantly building new features for our system or service, we need to ensure that these features will work with the current application. Instead of waiting until the end of the development cycle when all features will be integrated, we can now continuously integrate new features and test them as they are being developed. We can create what is called a CI/CD pipeline. These pipelines usually have the following distinct elements: starting trigger, building actions, testing actions, deployment actions, delivery actions. These CI/CD pipelines are usually where the largest portion of automation can be found. As such, this is usually the largest attack surface and the biggest chance for misconfigurations to creep in. Tools. GitHub and GitLab provide CI/CD pipeline capabilities and are quite popular to use. GitHub provides build agents, whereas GitLab provides a GitLab runner application that can be installed on a host to make it a build agent. For more complex builds, build orchestrator software such as Jenkins can be used. Jenkins, it is a powerful tool that enables automation, continuous integration, and continuous deployment in software development workflows. Its flexibility and extensive plugin support make it a popular choice for development teams. Case study: a tangle between dev and prod. One common misconfiguration with CI/CD pipelines is using the same build agents for both development and production builds. This creates an interesting problem since most developers will have access to the starting trigger for a dev build but not a prod build. If one of these developers were compromised, an attacker could leverage their access to cause a malicious dev build that would compromise the build agent. This would not be a big issue if the build agent was just used for dev builds. However, since this agent is also used for prod builds, an attacker could just persist on this build agent until a prod build is actioned to inject their malicious code into the build, which would allow them to compromise the production build of the application. 5 environments. Most pipelines have several environments. Each of these environments has a specific use case, and their security posture often differs. Let's take a look at some of the common ones. Development. User acceptance testing. Production. Pre-production. Disaster recovery or high availability. Other notable environments. There are some other environments that you may hear about when talking about DevOps. 1 green and blue environments. 2 canary environments. Refer the below points to know what exactly it is. Tools. Environments have changed significantly in modern times. Breakthroughs such as virtualization and containerization have changed the landscape. Instead of environments simply being computers, we can now have virtual computers created through tools such as Vagrant or Terraform. We could also move away from hosts entirely to things like containers using Docker or pods using Kubernetes. These tools can make use of processes such as infrastructure as code to even create software that can create and manage these environments. Security considerations. As mentioned before, the security considerations become more important the closer the environment is to prod. The underlying infrastructure of an application also forms part of the attack surface of the actual application. Any vulnerabilities in this infrastructure could allow an attacker to take control of the host and the application. As such, the infrastructure must be hardened against attacks. This hardening process usually requires things like the following: removing unnecessary services, updating the host and applications, using a firewall to block unused ports. Case study: developer bypasses in prod. One of the common issues that can happen with different environments is that often things that should stay in dev don't. Develop bypasses are common in dev environments for features like the following: multi-factor authentication, CAPTCHs, password resets, login portals. Developer bypasses allow developers to quickly test different application features by bypassing time-consuming features such as MFA prompts. A common example is having a specific one-time PIN code that is always accepted, regardless of the OTP code that is sent by the application. However, if there is inadequate sanitization of these bypasses before the application is moved to the next environment, it could lead to a developer bypass making its way all the way into prod. That OTP bypass? It could now be leveraged by an attacker to bypass MFA and compromise user accounts. This is why environments must be segregated, and similar to quality gates, security gates must be implemented to ensure a clean application is moved to the next environment. See in next video.